Good afternoon, class.
Good afternoon to you.
Welcome to this class of Geotechnology 1. So before we start, let's do a recap of last class where we tackled soil engineering properties. Can someone give me one engineering property that he or she remembers? Mereo.
We have the permeability.
Yeah, we have permeability of soil. Glorious.
Elasticity.
Yeah, we have the elasticity. Andrew.
We have the density.
Yeah, we have the bulk density of the soil. Gideon. Elasticity. We also have permeability. I can see you're still remembering. So in today's class, we are going to deal with volume weight relationship of soil. And before we start, let's look at the learning outcomes that you need to know. So the first learning outcome of this lesson is you should be able to state the three phases of soil. The second one, you should be able to define the term void ratio, porosity, degree of saturation, and water content. The third learning outcome is you should be able to calculate void ratio, porosity, degree of saturation, and water content of a given soil sample. So we are starting with the three-phase system. And I think you are very well conversant with this from our primary school education. We learned about the composition of soil. Who remembers the composition of soil from primary? Composition of soil. We said soil as air, water, and the solids.
And yes.
Yeah, so those are the three phases. So Kamlesh, can you read for us the second point that you can see in your screen?
Water and air is present in void spaces between the solid particles.
So the soil solids create a void in between them that can be either filled with water or air or both. So the void spaces can be partially or fully filled with water, or it can be partially or fully filled with air. So the diagram below represents the three-phase system where you can see the soil mass, and it has been rearranged so that the voids can either be filled with water or solid. So the weight of solid is represented by W3, the weight of water, WW, and the weight of air is unitless. You cannot measure the weight of air. And then the total weight of solid and water has been denoted by W1. I hope you can all see that. And on the other side, we have the volume. So the total volume is represented by V1, the volume of solids by Vs, the volume of air or water, Vv, which can be divided by Va and Vw. Amuniski? Sijamute? Umeharibu. So we are starting with the volume to volume relationship. So the first one, please Gideon read for us.
Volume ratio. This is the ratio of the volume of voids to the volume of solids.
Yeah, void ratio is the ratio of the volume of voids to the volume of solids. So you can see from the formula, you denote void ratio by E. So E equals to VV, which is the volume of voids, over VS, the volume of solids. So fine-grained soils have a larger void ratio than coarse-grained soil. Does that statement make sense?
Yes.
It does. Fine-grained soil have a larger void ratio than coarse-grained soil. The voids between the solids, which one has a bigger void?
A coarse-grained soil.
According to Kamlesh, he's saying the coarse grained soil. Anyone with a different opinion? Yeah, no, it's the fine grained soil that has a larger void ratio than coarse grained soil. Coarse grained soil has a larger size of voids but less volume, while fine grained soil has small but. Read for us that statement, Kamlesh.
Yes, coarse-grained soil has large sizes of voids but less volume, while fine-grained soil has a small volume of voids.
Yeah. So, Gloria, read for us the second statement.
This is because the fine-grained soil has a large surface area, hence increase in voids, and vice versa for coarse-grained soils.
Yeah. So the second one is porosity. Vincent, can you read for us porosity? Vincent, unmute.
Oh, porosity. This is the ratio of volume of void to the total volume.
Yeah, porosity is the ratio of the volume of voids to the total volume. So as you can see, void ratio and porosity we are dealing with ratios of volume. That's why you're calling it volume to volume relationship. So porosity is also known as percentage voids, and the formula is given below, where porosity is denoted by N. So N equals to VV over V. Okay, down there you can see how we can relate porosity to void ratio, where we have taken the reciprocal of porosity, which is volume of void. The reciprocal is volume over volume of void. We break down that we know the total volume is volume of void plus the volume of solid divided by the volume of voids. So volume of void makes 1 plus Vs over Vv, which is the reciprocal of the void ratio. I hope you understand that how we have derived the relationship between the volume of void and the porosity. So the third is the degree of saturation. Edmond Kangogo, can you read for us? Edmond, read for us degree of saturation. You're not audible. Please, Sandro, read for us.
Degree of saturation is the ratio of volume of water to the volume of void.
Yeah, volume of water to the volume of voids. So when the soil is absolutely dry, so we'll have 0 volume of water, and that will give us 0. And when the volume of water is 100, we have 100% saturation. Now we are going to mass relationship, where we have the water content, which is the ratio of mass of water to the mass of solids. It is also known as moisture content and can be expressed as a percentage by multiplying it by 100. There is the formula, W equals to MW over mass of solids. So in summary, we have said both porosity and void ratio are measures of density or looseness of soil. So as soil becomes dense, the value of porosity and void ratio decreases. The voids of soil that is partially filled with water also has air, but voids that are fully saturated with water has 0 air, and fully dry soils have 0 water. Since all of this, we are dealing are ratios of volume to volume or mass to mass, they are unitless unless converted to percentage. And that's the end of our class. And these are the assignment that I'll be collecting in our next class, where we will be covering volume to weight and volume to mass relationship. So there are some questions I've sent to your class representative. He will share with you, and I'll be collecting it in our next lesson. Thank you, and let's meet in our next class.